My dear lovely students, how are you? I hope you are quite well and your study is going very smoothly. Today, we are going to discuss aldol reactions. This is lecture number 19, part A. Why I'm telling you part A? Because aldol reaction, you will see the part A, part B, and part C. So, in this part, we are going to understand the aldol reactions. Whenever we talk about aldol reaction, students see that aldol reaction we will study today. One, aldol additions reactions, and second, aldol condensation reactions. Okay, so two things we will understand, students, here. That is the one, aldol addition reactions, and second, aldol condensation reactions. Okay, students, see that whenever we talk about aldol, aldol means what? That is the combination of aldehydes and alcohol. When aldehydes and alcohols means all both are combined, you will get that what? Aldol. Correct? So it means in aldol reactions, the formation of aldol, whenever the aldol will form, they have aldehyde group as well as alcoholic group. Okay. Student, the most important thing is that who will involve, what type of reactant will involve in the aldol reactions. The first and most important condition is that carbonyl compounds, carbonyl compounds must have alpha hydrogen. Correct? So those carbonyl compound which will have alpha hydrogens, that will undergoes into the aldol reactions. Okay. Second part, students, aldol reactions can be happen with the strong base as well as weak base. Here in your NCRT, the aldol condensations is carried out in the presence of weak base. So we take here the base is weak. That means we will take weak base like NaOH, like KOH, like calcium hydroxide, like lithium hydride. This base we will use here. Now third is that solvent. Strength solvent we will use here polar protic solvent. Student, let me tell you one thing for your knowledge. Aldol condensations can be happen with the strong base as well as weak base. Whenever we take the weak base, we always use solvent as a polar protic solvent. When we use the strong base, we use the polar aprotic solvent. A strong base is the LDA. LDA is the strong base, right? But here we are not discussing today the LDA. Simply, first we understand the polar protic solvent, and that is used in the aldol reactions. Okay. So either in the lecture number B or C, I will discuss the aldol condensation with a strong base and what the consequences will be there. But now here is that simply weak base like that we will use here. Student, let me tell you one thing. In the NCRT or in different week, you have seen that aldol reaction is reversible. Student, aldol is a reversible means aldol is equilibrium process. Aldol is what? Aldol is equilibrium process. It means what? Student, it is a equilibrium is a aldol is equilibrium process means. So why it is going to be happen in the equilibrium process? Student, whenever you take the polar protic solvent, in with the carbonyl compound, they always undergo into the equilibrium process. Correct? It means when we take the strong base and the polar protein, aldol will not be the reversible process. Done? Understood what I'm telling you? The aldol is equilibrium process. Why? Because because you use because carbonyl compounds react react with the base in the polar protic solvent. So carbonyl compound we use what use? We use polar protic solvent. That is the region that move into the equilibrium process. Okay. Now the next point is that students see that in the aldol reaction we are using here we are going here with the base catalyzed aldol reactions. So this is the base catalyzed aldol reaction. It means yes, for better understanding we will understand the acid catalyzed aldol reaction too today, so that when you will understand the acid catalyzed aldol reaction strengths, your concept will be 100% clear on the aldol condensation reactions. Now we talk about the base catalyzed aldol reaction. See here. So first we don't go to the mechanism. We understand because every time if we have a given question, then how we can every time we cannot go with the mechanism. So all reactions you can't every time you use the mechanism. So what happened? Suppose you have CH3 C double bond OH, right? And one more compound I take the same because we understand here self aldol. Self aldol. So what happened? Again we take here CH3 C double bond OH. So when we'll take the NaOH, so what happened? And NaOH. So what happened with the NaOH and water? Students see that uh, H, this CH3 group can we write here like that? How H CH2 C double bond OH can we write like that? Yes, we can write like that. So H attach exactly this compound we can write like that. So H will go to this oxygen attack on the oxygens, and the rest of the portion will directly come to that carbonyl compound. So ultimately, what we will write here, CH3C OH, right? Here is the H, CH2, C double bond OH. C. Whenever the questions asked about the aldol, that is the aldol, because you can see alcohol, aldehyde, both group attached here. But yes, whenever they ask the condensations, then of course the dehydration will take places, water will loss, and the dehydration will happen. Dehydration will happen, and that is the strength. All the things are reversible process. So just keep in mind here. So CH3, CH double bond CH, C double bond OH. Okay. If you want to bring directly the condensations product, you can write in this way: C double bond O H CH3 plus H2 CH C double bond OH. So OH2 will remove here. Directly you can write here CH double bond CH C double bond OH. Okay, that's fine. So if you want to write the directly the condensation, you can write like that. If you want to bring, if you want to write like the aldol, you can write here, and then uh, uh, dehydration takes places, and then you can get the condensation product like that. So in any way you can write here. It's depend on the what the desired product you have. Now the main point is that we understand here the base catalyzed reactions. Students, base catalyzed reactions. See here. First, what will happen? First, step first. Step first. Student, why you understand the mechanism? Because whenever the question will come twist like that or something is different, then how you can solve the questions? Logically, if you want to solve the question logically, if you want to questions any twist questions, then you have to understand the mechanism. See, step one is that formation of enolate ions. First is that to form the enolate anion. See strengths. Those students who understand the tautomerism, they can understand very easily this whole topic because it is similar to the tautomeragism, because tautomeragism also you can get the enolate ions. So to form the enolate ions, why we form? See that. Students CH2H C double bond OH. Okay, as you know, the carbonyl group strengths, the carbon which attached with the carbonyl group, which is highly acidic, means their hydrogen is highly acidic. This hydrogen is extremely acidic. So we have a base, OH minus base, and strengths we use the base in a very less amount, maybe 10% or 20%. So keep in mind, base we use the less amount, reactant we use the larger amount. So base will attack on these protons and remove the water, and what you will get that CH2 negative C double bond OH. C double bond OH. Okay. Now strength, here is resonance, and you can get like that O negative and H. This is the enolate anions. Okay. Enolate anions, right? Students, do you know one thing? This enolate anions is ambident nucleophile. What? Ambident nucleophile. Okay. Now, since it is ambident nucleophile, so that means no, it is nucleophile. So it is nucleophile means your next carbonyl compound will act as electrophile. So students, that's not necessary. That next carbonyl compound would contains the alpha hydrogens not. But first compound you must take the which generate the good nucleophile, because once the one substance is a nucleophile, other substances will act as electrophile. And next is the ambident nucleophile, means that can attack on the next carbons either from this carbon side or from the oxygen side. That is the ambident nucleophile now. So those which have two donor sides. But point is here, yes, carbon can donate electrons, but why oxygen will not donate electrons? Students, this is whole process is thermodynamically, means you have got that enolate ions. So this enolate ion is thermodynamically you have got that. What? Thermodynamically you got that enolate ions. Thermodynamically you got that, means this enolate ions is the most stable enolate ions, right? So thermodynamically, when the oxygen will attack on these carbons, that thermodynamically the bond will be the carbon oxygens. That is thermodynamically unstable bond will form. That is not a feasible, right? So therefore, this carbon means in the enolate ions, the carbon will attack on the next carbons. So once you got the enolate ions, next what happen? You have a second carbons, C double bond OH. Now this time this carbon compound act as electrophile. So CH2 negative, C double bond OH, right? Now what happened? It will attack here, and this is the whole process is the reversible. CH3, once it will attack here, C O negative H and CH2 C double bond OH. Now again the protonation will take places. HOH, it will attack on these hydrogens. So OH minus will remove. This is the whole process. Earlier I said this is the reversible process. So what happened? CH3, C, OH, H, CH2, C double bond OH. This is the aldol. Okay. So one thing you can observe, students, in aldol, one hydrogen will require. Correct? No. Next, why I am telling you, because in the next, after finishing of this whole questions, I will give the questions. At that time, you have to tell me whether this reaction will involve in the aldol or not. Okay, now we'll go to the dehydration, means second stage, that is the condensation process. So in the second part, that is the condensation part. So in the condensation part, what will happen? See that CH3, student, one thing is very interesting. Once the reaction will reach on the aldol part, correct? So then reaction would be the reversible, means backward and forward. Okay, so we will understand the whole process in the aldol condensation part B, that is a retro-aldol, that we will understand there. So now here is that CH3, COH, okay, here is the H and CH, H, C double bond OH. Students, when you have a base, because you have base, there is a base, so now you have base OH minus, that will attack on the hydrogens and water will remove. So what happened? Strength CH3C OH, H, CH negative, C double bond OH. What do you, students, did you observe one thing here? What? Negative ions means negative charge comes on the carbon. So that now, as you know, OH is very good nucleophile, not a good living group. But here OH will leave the positions, right? So OL leave the positions, OH act as a living group, okay? And so that what will happen? CH3, H, double bond CH, C double bond OH. Can you tell me one thing, students? What mechanism here used? What mechanism followed here? Through what mechanism we got the product here? Just you think, students. Students, this is the name is called, the mechanism is called E1CB. So those who are the neat students, that's not a worried about this mechanism, because such type of things will not come. But for general knowledge or for JEE students, that's a very, very important part here. Students, this is the whole part is the E1CB mechanism, means unimolecular conjugate base. That is the unimolecular conjugate base. This is the mechanism. Students, this mechanism is different from the E1 and E2. It is a typical mechanism. Okay. So through this mechanism, now let's see that. Students, one thing I'm telling you, when you have a carbocation is generated, whenever the carbocation is generated, usually Setjeev is followed. Setjeev rule is obeyed. Okay, correct. So in that case, Setjeev rule obey means more alpha hydrogen is more stable. That means more alpha hydrogens more stable. You get that. Okay. So if you have a carbocation generated, then Setjeev rule away, and the more alpha hydrogen means more stable. Correct. But students, do you know one thing? If you have a carboanion is formations, if the C negative is there, okay, in that case, Hoffman, what I'm telling you. So if you have a given that in that case, Hoffman product is formed. Hoffman product is formed. That means E1CB mechanism will follow. When you have a carbanion, if you have a carbocation, the Setjeev rule, usually Setjeev rules are there. But if you have a carbanions is carbon negative charge, then the Hoffman product will follow. That means E1CB rules is applied there. That means less hydrogens, less alpha hydrogens, more stable like that. Correct? So students, that is the reason here that the logic is E1 mechanism is E1CB is applied there. Correct? So I hope you understood here all things. One more thing, students, keep in mind. In the base catalyzed, what you can observe? One, base catalyzed mechanism follow the one E1CB. I'm talking about dehydrations. Mechanism follow the E1CB. Still, acid catalyst mechanism follow the E1 mechanism. Acid catalyst, suppose the aldol condensations, we understand right now here. So in acid catalyst, the dehydration takes place through the E1 mechanism. That means that time we will use the Sergi product. So here in the base mechanism, we use the E1CB mechanism. That is the less alpha hydrogen is the more stable. Second is that enolate ions attack on carbonyl compounds. Correct? Two things you can observe from this whole logic. Okay. Now, those students who understood the mechanism perfectly, I asked to you the two questions. The question number first, you tell me, students, what I'm asking you. The CH3, CH2, C, CH3, H, and C double bond OH. My question to you, the number one, the reaction will follow aldol. It will go into the aldol reactions. Option second, it will go into the aldol condensation. Third, it will go into both, and fourth is neither. Can you tell me? If you understand the mechanism, you can tell me very easily this whole the concept, the questions. You can give me the easily their answer. Please tell me what the answer will be there. Will they involve in the aldol reactions, aldol condensations, both or neither? See strengths. You can observe one thing. In the aldol, one hydrogen is removed. That will generate the enolitines. In the aldol condensations, another hydrogen will remove and they form the alkene. So for the aldol condensation, you must have two hydrogen strengths. But here is only one hydrogen in the alpha positions. It means that reaction will only move into the aldol reactions. That will not go into the aldol condensation. Okay. Now my next question to you: can you tell me what the product of these reactions? CH3, CH double bond CH, CHO. I have taken the 2 moles, and that is the dilute NOH, right, water. Now tell me, students, what product will form? Just you pause the video and try to solve the questions. I'm not going to give you the option. Okay. See, students, what the things will happen. See, CH3, as you know, this is the alpha hydrogens, correct? So what will happen? Here is no alpha hydrogen. So CH3, CH double bond CH and C double bond OH. So when the base will take OH minus, that will attack here and generate the what? CH2 negative, CH double bond CH, C double bond OH. Okay, and then what will happen? CH3, CH double bond CH, C double bond H, and you have this nucleophile that will attack here. So what will happen? CH3, CH double bond CH, CO negative H, CH2, CH double bond CH, C double bond OH. Now you take the water, protonation will happen, and then the CH3, CH double bond CH, COH, H, CH2, CH double bond CH, C double bond OH. And then dehydration will take place, water will loss here, and that will form the CH3, CH double bond CH, CH double bond CH, CH double bond CH, C double bond OH. Still we can write this one, second and third. So CH3, CH double bond CH, all three C double HO. You can write this simply. This product I have solved this question through the mechanism, but you can write simply. How to write this simply? You can write in here is that simple manner that see that how to write here. See, that is the CH3. Okay, CH double bond CH, C double bond OH can be right here, plus exactly repeat it, H2 C H, CH double bond CH, CHO can be right here, and OH2 will remove, directly generate the product. Directly generate the product here, CH3, CH double bond CH, CH double bond CH, CH double bond CH, and CHO. So here is 1, 2, and 3. So you can generate like exactly product directly, but for your understanding, I solve through the mechanism. Now, students, we go to that understand the acid catalyzed mechanism. See, through acid catalyzed mechanism, you will understand perfectly the base catalyzed aldol condensation. So just we understand here that the acid catalyzed mechanism, that how to generate that. In the acid catalyst, what things will happen? See here, students. Uh, suppose you have like that CH3, okay, so CH3, C double bond O, CH3. Here is that this is the acid catalyzed. So through the acid catalyzed, you tell me what things you can observe, what things you will have to understand here. See, 2 moles we have taken here, the SCl we have taken like that, and then the whole processes will be 2 moles. So CH3, C double bond O, CH double bond C, CH3, CH3, you will get that. Okay. Now understand strengths of how it will happen, because in the although the reaction of the acetone with that calcium hydroxide given in NCERT, that is the basic parts, the basic way, but also you have given the NEET exam in the acidic reactions. So now see here, first the protonation will happen, double bond O, CH3, you have a HCl, H plus Cl negative. So that the lone pair will attack on the proton, and what will happen? CH3C, OH CH2Cl. Can we write here CH3 like that? CH3 can we write CH3 like that, CH2 and H. Okay, CH2 and H we have it right here. And now you have a Cl. So Cl negative will attack here and then generate the C. Oh, sorry. Then here like that C and C OH and here is CH2 negative. Now you will get that enolate ion CH2 CH2 not CH3 CH3 C OH double bond CH2. This is called enolate ions. Okay, so now you got that enolate ions. Students, see what happened in the next step, that your enolate ions, which is CH3C OH, right, and double bond CH2 attack on the protonated carbonyl compound, means CH3 C OH cation CH3. What I am telling you, actually difference in the base catalyzed aldol and acid catalyzed aldol is that, students, keep in mind what I am telling you. In the acid catalyzed, enolate attack on the carbonyl protonated carbonyl compounds, right? And second, the dehydration will follow the even rule. Okay, so now it will attack here. Here bond will move, and this is the that part will come here, and so that CH3 C double bond OH CH2 here is that, and C OH, okay, and CH3 will form. Now students, see whatever there is a proton will transfer here. There is proton will transfer here, and in that process, what is going to be happen? That CH3 C, once the proton will transfer here, students, C double bond O. Now CH2 C OH H CH3 and CH3. Now water will remove, and then CH3 C double bond O CH2 C cation CH3 CH3 will form. Now you have taken that Cl. Remember that Cl, because here is that Cl is there. In that part, the Cl will remove. Again, you have taken that. So Cl. So Cl will attack on these hydrogens, and then that will form the CH3 C double bond O CH negative C CH3 CH3 will form. Now students, here is the positive, that will form the CH3 C double bond O CH C CH3 will CH, right? So what can you observe here? That is the double bond formation is the what product is there? That is the set G product. Set G's product will, you will get that. This is the whole process is the dehydration is the process. This is completely dehydration process. So all this dehydration process will takes place as the E1 mechanism.